And for our last step in solving this equation, as you recall, when we left off, we had just gotten rid of a 2 on each side, so we are left with the one-step equation 5x is equal to 15. So last but not least, I need to get rid of the 5 that is along with the x. In other words, so I've got multiplication right here. I've got x 5 times basically. So I'm going to take these guys and I'm going to divide them up. And when I say I'm going to divide them up, I'm literally just going to take them and like drag one here, kind of drag them apart so that they're separated. I'm going to divide them into 5 groups so that now they're kind of separated. On paper, what that looks like is I'm taking those 5 x's and I'm dividing them up into 5 groups so that now each little group of x's only has one x in it. So now each x is all by himself. I literally kind of took them and imagine that I kind of like divided them up, put little walls in between them, divided them into 5 groups so that now there's just one x in each group. If I divide up the left side here, of course, I still have to divide up the right side. So because I divided the left side by 5, I have to divide 15 by 5. And I hope that we know 15 divided by 5 is going to give us 3. So what my model would look like is I'm going to take this 15 and I'm actually going to divide it up. I'm going to click on the little boxes and I'm going to turn these into 3s. I'm going to drag one of these guys over here. Turn it, double click. Turn them into a 3. Oh, I already have a 3. And another 3. And I can find another 3, but I'll just double click and turn that one into a 3. So now I have concrete proof of the equation 5x is equal to 15. Every one of these little x's has to be equal to 3. If I'm counting it right? Because it would have to be 3, 6, 9, 12, and 15. So I've actually used a model to explain why x must be equal to 3 if 5 of them balances out to 15. So my final answer is x is equal to 3.